welcome back to another video from Ionbotics. Today we're going to program the STM32F103 to blink an LED each 1 second. Perfect. So what do we need in order to do this task? We need the ST-Link programmer version 2 that we got from eBay, very cheap. You can take a look into the comments where you can buy it. The STM32, a 220 ohm resistor, an LED, a little jumper cable or any cable in order so you can plug it in to port C, pin 13. Okay? I'm going to use this cable in order to connect my computer to the ST-Link. Perfect, guys. So let's get started. Okay, how do we plug in the ST-Link? So here we see this white mark on the top that tells us the position of this socket. So this slot here shows us which pin is which. So the top left corner, if we flip it like this, the top left corner is pin 1. We're gonna plug in to pin 2, 4, 6 and 8. Here you can see it better, guys. So software clock, SWCLK, software digital input output, SWDIO, GND ground, 3.3 volts. Okay, so brown, white, black and red. If we take a look into the STM32, we can see ground, clock, digital input output, 3.3 volts. Perfect. So now let's plug it in. Now that we're in, we're going to connect this to our computer. And we're going to program the STM32F103. Perfect. Now we're going to upload the code to the STM32. So let's click here on the CubeMX icon. Let's open CubeMX software. Now we're going to click File, New Project. And we're gonna, on the browser bar, we're gonna select STM32F103C8. So that's the board that we're using right now. We're gonna select the board, and then we can take a look into the datasheet if we want, or the documentation, but we're gonna click on the Start Project. So now it's gonna start a project for us. This shows the microcontroller, all the pins, the IOs that the microcontroller has. We're going to click on A to C, then we're going to click on System, and we're going to make sure that we have a debugger via serial wire. Once we do that, we're going to select RCC. Okay, if we hover over it, it tells us it is reset and clock controller registers. So we're going to click on the RCC registers, and then we're going to click on high speed controller, high speed external oscillator. So we're going to click on the crystal. Remember that it was 8 megahertz. And now that we have the clock configured and enabled, we're going to configure the clock. We're going to click on high speed external oscillator. We're going to click on the PLL clock. We're going to notice that the maximum speed of the microcontroller is 72 megahertz. In order to achieve 72 megahertz, we're going to modify our PLL multiplier. So we're going to make it multiply times 9 to get the 72, because it was not being divided by anything, it was divided by 1. So the 8 megahertz from the microcontroller divided by 1 gives us 8, and then 8 times 9, 72 divided by the prescaler being at 1 gives us 72 megahertz. But now we got an error on the APB1 peripheral clocks, because this one can only operate at 36 megahertz. So we're going to divide this one by 2. We're going to take the APB1 prescaler and we're going to set it up to 2. So there you go. We have just configured the clocks for our microcontroller for the STM32F103. Now we're going to go to the GPIO ports, to the register of the GPIOs, and we're gonna click on port C pin 13 where we plugged in the LED. We're gonna select GPIO output. Now the GPIO output is gonna appear on the GPIO registers We're going to click on it and we're going to configure it. So we want the output level of this GPIO to be high. We want the mode to stay as output push pull. We don't want it to be open drain, otherwise the pin is going to be left floating. We're going to select a pull down resistor. And now we're going to click on maximum output speed of the highest output speed of the port. Now we're going to go to Project Manager tab. And we're going to give the project a name. So we're going to click this one, Lab 1 Blink LED. Now that we gave the project a name, we're going to select in which folder we're going to save that project. So we're going to click here on the Ionbotics folder, and I'm going to open there because there's where the project is going to live. And we're going to select which IDE or which software we're going to program the microcontroller with. So we have Keil Microvision version 5, so it's MDK ARM version 5. So we click that one, then we're going to go to Code Generator. We're going to make sure that we copy all the use libraries in case that later we want to add an extra peripheral. Basically that's it. We can click Generate Code. Now the software is going to auto-generate the code for Keil Microvision. It's going to generate it in C. And we're going to open the project. We're going to expand this folder, and we're going to expand the folder name Application User. Now we're going to see that a file main.c lives there. There's where our software is going to live. There's where our software we're going to write it. So the auto-generator code gives us all these comments that we can take out because they are not used. We do need to leave this copyright section. So, but on the other side, we can take all of these ones out. We can take all of these ones out. We can remove these ones. I like to leave some main titles, like for example, microcontroller configuration, MCU configuration. I would like to take all of this out. These are comments that are just going to confuse us later on. So only the main titles we should leave. And this is going to be our infinite loop. While 1 is an infinite loop and is where our application is going to live. If you are familiar with Arduino, this is going to be the void loop. I'm going to add a comment here that says and while infinite loop. Perfect. So now that we have that infinite loop while and we know where the bracket is going to end, we also notice that there are two functions that have been defined automatically by the autocode generator. So we have the system clock configuration and the CubeMX GPIO initialization. So the clock configuration is the same configuration that we gave, and it sets up all the prescalers in order to give us the value that we wanted at the end, that was 72 megahertz. This is what this function is doing over here. And this function over here is setting up the GPIO port pin 13, if we can see here. Pin 13, port C. So these are all HAL libraries and HAL functions that the code generator selects. Now we're gonna quickly program the LED. So we're gonna HAL GPIO toggle, and then we're gonna tell it which GPIO we're gonna toggle, which port GPIO C. GPIO pin 30. Sorry, 30 brackets, and then we're gonna do a blocking delay. Delay, and we're gonna say 1000 milliseconds. This delay is in milliseconds, and every 1000 milliseconds it's gonna toggle the pin on and off. Now, before we upload the code, we have to configure the programmer software. So we're going to click on options for target. We're going to select 8 megahertz, that is value of our crystal, of our physical crystal in the board. We're going to click on debug. We're going to go to settings, and we're going to click on flash download. We're going to click on reset and run. This means that every time we load a new code to the board is going to reset automatically. Otherwise, we will have to click the reset button every time we upload a new code. If we click on this description, we have to make sure that this is a 1. Sometimes it appears at 2 depending on the board, so that's fine. And then on trace, we also make sure it's an 8 megahertz, although this is not enabled right now, but I like to leave it already. And we're gonna click OK. So then we make sure everything is fine, everything looks all right. We click OK. Now we click on build, or we hit the F7 key in our keyboard. The compiler builds up the code. It takes a little while. We're doing it together here. Once it's done, load. Perfect. Now we can see the LED is being toggled every 1 second. So now let's speed it up a bit. We're going to click 500 milliseconds. We're going to again load. This time is shorter. And then we're going to click load to the board. Perfect. Now let's speed it up even more. So now 100 milliseconds. So now I'm going to load it up. And then download the code. Great. Now we know how to toggle an LED pin from an STM32F103 board. It was easy, right? Just like an Arduino. Alright guys, on the next video we're gonna get a little bit more complex. We're gonna take a look into SPI, and we are going to plug in the barometer sensor that we soldered last video. We're gonna program in the SPI and we're gonna get some values on the STM32F103. If you like the video, click like, and don't forget to click on the button, subscribe, and see you next time.